Hi guys, today we're learning lesson 99 and we're going to be going over inverse variation. We've worked with direct variation before, so let's go ahead and review what that was. Direct variation was the value of one variable can be found by multiplying the other variable by a constant. So we have the formula y equals kx. And remember when we talked about this, this is like if I made $10 an hour and I worked 1 hour. So let's just go ahead and do a chart and let's see what that looks like. Okay, my pen isn't wanting to work, sorry. Okay, so if I had my x's and y's and I worked 1 hour and I made $10, if I worked 2 hours, I'd make 20, and 3 hours, I'd make 30, right? But can we solve for k? Let's see if we can solve for our k constant. Let's say if we didn't know I made $10 an hour. Well, what's happening in my equation here? What's happening to my k? It's being multiplied by x, right? So we can just divide by x on both sides to solve for k and get k all alone and isolated. So k will equal y divided by x. Okay, so this is direct variation. Remember what direct variation looked like, the graph? It was a straight line and it went through the origin, it went through point 0, 0. So if I worked 0 hours, I made $0. And in this instance, if x is 1, y was 5, and so on. Okay, so direct variation is a straight line that goes through the origin. Okay, indirect variation is a little bit different. Inverse variation. Inverse variation says the product of two variables is your k constant. So the formula for inverse variation is y is equal to k divided by x. Y is equal to k divided by x. And we need to have these memorized, guys. Okay, so can we solve for k? Same instance here. K is being divided by x. So we're going to multiply both sides by x to get k alone. Yep, sorry. I need a better pen. And if we do that, these cross cancel and we get k is equal to x times y. Okay, so that's our formula. That's when we solve for our k constant, and that's what it says. Inverse variation says the product of two variables, equals my k constant. Okay, so the easiest way I can describe inverse variation is by talking about a pizza. So if you're starving and you come home and there's only one of you, how many slices do you get? You get 8 slices. So let's say you put your pizza in the oven and this whole pizza is for you because you're starving, right? Your eyes are bigger than your stomach at this point. But somebody else comes in, you have a sibling come in and says, oh, that smells good. I want to share it with you. Well, how much do you get now? You get half of it, right? All right. Then you have a couple more family members come in. We got 4 people now. So how many slices do you get? Our k constant hasn't changed. We still have only 8 slices of pizza, but now you only get 2. And then wait, somebody else comes in, a couple neighbors come over. Now you have 8 whole people smelling your pizza that's in the oven, and how much do you get? You get this one little slice, okay? So that's what inverse variation is. Inverse variation says as one variable goes up, the other variable goes down. So as my x's go up, the number of people that I have go up, my portion slices go down, okay? Now, because my pizza hasn't changed. So what does that look like as a graph? Let's take a look. Well, if I have one person, they get their 8 slices, right? And then if I have 2 people, they come in and they get 4 pieces each. And if I have 4 people come in, they get 2. And 8 people come in, they get 1. So my graph is always a curved, sorry, need a better pen, curved line. Okay, so it's got a curved line. All right, so another example of inverse variation. So let's say you live 90 miles from the beach and your family travels 90 miles to the ocean. If you average 60 miles per hour, the trip will take you 1.5 hours, right? However, if you stop along the way, your average speed varies. So this affects your travel time. But what is my constant, my distance? It hasn't changed. I still live 90 miles from the beach, right? But if I'm going 60 miles an hour, I travel for 1.5 hours. But if I go slower, it's going to take me a little bit longer. If I travel 40 miles an hour, it takes me 2.25 hours. Or if I go really slow, or if there's traffic, or if I stop a lot, and I average 30 miles an hour, it takes me a whole 3 hours to still go that 90 miles. My distance is constant, that didn't change. But as one variable went up, the other variable went down, right? So as my travel time went up, my average speed went down. Okay, now let's see. Saxon Math is also going to say, determine if the variables in the tables A and B are inversely proportional. Inversely proportional, and explain how you made a determination. Well, remember, we came up with our formula. K, our constant, is going to equal to x times y. So let's go ahead and do that. X times y in A. 2 times 4 will give me 8. 3 times 1 will give me 3. 4 times 3 will give me 12. Do I have the same kind of constant here? Nope, I don't. So this is not an example of inverse variation. Okay, so this is not inverse variation. I guess I can get rid of, I didn't write the word example. So let's look at B. Okay, x times y. X times y should equal my k constant. 4 times 2 gives me 8, 1 times 8 gives me 8, and 4 times 2 gives me 8. So is my k constant the same here? Yes, it is. So this is an example. So this is inverse variation. Remember, as one went up, the other went down. Okay? All right, one last thing to remember. So let's go over these. Okay, the direct variation. Remember, if I'm paid $10 an hour, if I work more, I get paid more. And my k equaled here, to solve for k, we're going to divide by x on both sides. And then k will equal y divided by x. And what is my graph? It goes, let's say it goes through my origin. Point 0, 0, right? And then it is a straight line. Okay. Now, inverse variation, this is my equation. Y equals my k constant divided by x. And if we solved for k here, remember we had to multiply both sides by x. And then k equals x times y, right? And my graph, it's always a smooth curve or a curved line. Okay? So that is the difference between, direct and inverse variation. All right? Okay, that's it for today. You'll have some examples in Alex, and your next Alex assignment will be up. As always, if you have any questions, feel free to email me. Thanks a lot. Have a great day.